everyone. Good morning. Respected authors and invited guests. Welcome to the Technical Session 14. For myself, Gayatri Dhurpuri, this session will be moderated by me. On behalf of Global Knowledge Research Foundation and Geoscholastic, it is my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communications, that is SMARTCOM 2026, Pune, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is held today in Pune, India, and the virtual event is being held through Zoom from 19th to 21st January 2026. I hope you'll enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answers. Upon 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. Have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for the current session. Dr. Prasanna Jayachan Shetty is an associate professor in the Department of Computer Engineering at KG Somaiya School of Engineering, Mumbai, Maharashtra. He currently holds several leadership roles, including head of the department, convener of the Equal Opportunities Cell, and coordinator of the KJ Resource Center for Students with Disabilities. His research interests include ad hoc networks, cross-layer design for quality of service in multi-hop wireless, ad hoc network, while computing. Sir, would you like to address the participants?
Yeah, ma'am. Good morning, everyone. Congratulations that your paper has been accepted for the SMARTCOM 2026.
Thank you, sir.
Without
Now,
taking much of time, I think we should start the session and later follow the same schedule, the order of the presentations.
yeah, sure, sir. Thank you, sir. Now I would like to start with the presentation. I would like to call upon our very first presenter, Mr. Alkapalli Krishna Likith, to present their paper titled A Multi-Tool RAG Framework for Automated Content Summarization and Interactive Conversational AI. Mr. Likith, over to you. Hello, Mr. Likith, are you there? I'm not getting a response from Mr. Likith, so we can move to our next presenter. My next presenter is Mr. Harsh Basil to present the paper titled Flexibility of Universal Sentence Encoder in Diagnosing Depression. Mr. Basil, over to you.
Good morning, ma'am. Am I allowed to share my screen?
Yeah, just a second. Stop sharing. Yeah, you can share your screen now.
Thank you. Good morning, all, and it's a pleasure to present my paper on SmartCon. First of all, I'd like to thank the committee and the session chair. Without wasting any time, I'll straight away get to the problem. So the point is that we are going to present our work on the applicability of universal sentence encoder in diagnosing depression. We understand that it is a very important problem. Depression, as we know, is a mental health disorder. It affects mood, thinking, behavior. This is what we know. The point is that it affects our daily life, it affects our near ones, it affects our productivity. So it is a very, very major problem, and this is what we cannot ignore. As a matter of fact, dispensations and governments all across the world are trying their best to do something regarding depression, given the impact of social media and text data. So the point is that it may lead to cognitive impairment. It also leads to decision making difficulties. So there are many challenges associated with depression, and it's a cognitive health challenge. It's a global challenge. Now, why I say that it is a global challenge is because we understand that approximately 280 million people worldwide are affected with depression, approximately 3.8% of the world population. And many of them remain undiagnosed. Why they remain undiagnosed, we'll talk later. So 60% of the individual, they also exhibit cognitive impairment. So I was saying that there is some sort of memory loss, there is some sort of cognitive impairment, there is some sort of difficulty in decision making. This is the reason. And like the point is that many people from these people die from suicide. The depression goes to such a level that they commit suicide, which is highly problematic. So it is strongly associated with suicide, as I told you, and it increases the risk of neurodegenerative conditions. Alzheimer's is something which we are working on. So it is a problem. And it disrupts the personal, social life. And like why we are working in this direction is because as of now, SAQs is the most important thing from which clinicians diagnose depression. It is self-assessment questionnaire. Now, when we say self-assessment questionnaire and when we talk about the interviews which the clinicians take, we understand that there are many problems. Why there are many problems? Because it is manual, first point. It is time consuming, intensive. And the point is that the existing models and they lack cross domain generalization. We are working in the text data, and in text data there is a problem. Now, in spite of all the advances that have been made, the number of samples, clinically approved samples are very less, and the text is generally very large. So even good LLMs are not able to comprehend depression sort of a thing. Now, what is our problem statement? Problem statement is we want to detect depression from text data, and it has been obtained from the DIAC-WAS dataset, particularly in the setting when as I told you, where the number of samples is low and the text is large. So this is one of the problems which we are dealing with, and this is the reason we used universal sentence encoder and not transformers and LLMs. Though we tried that also. I'll tell you later. So we saw the existing state of the art. I understand that we have limited time here, so I'll just summarize what we saw. The earlier works actually focused on TF-IDF. So the earlier work focused on the frequency of the words, the association of the words with each other. And later on, the scientific fraternity realized that there is a problem. We moved further. We used things like LSTM, GRU, bidirectional RNNs and all. We realized that, again, there's a problem if the sequence is too long. We moved further and we actually embedded the text in certain ways. So earlier people used text level embeddings, and the text level embeddings were of many forms. So like there were many empirical studies comparing various text level embeddings and word level embeddings and the association between them. Again, the problem persists because if we make a highly advanced model, then the number of parameters of that model is too large and the number of samples given to us is limited. So this is one of the problems which we face. Again, so we have used data set and we have used a standard data set. There's a reason of using standard data set. So this is something which I've been doing since with my students, and I wanted to use a standard data set so that we can implement the model, compare it with the existing state of the art, and then generalize it further. So we have also got data from one of the hospitals at Delhi. It is RML hospital, but we first wanted to test our model with the existing data sets and see if it is working well. So the data that we have used is a text only data. It has 154 controls and 65 MDDs. So it is slightly imbalanced, but still our model is working fine with different data sets also. Again, so as you can see, it's a standard machine learning pipeline. We have pre-processing, feature extraction. We have used universal sentence encoder embedding. We earlier also used Elmo embedding, but we saw that USC is working better. Then we did the feature selection using Fisher discriminant ratio, which is a filter technique, and we did the classification. Broadly, this is what we have done. So the point is that, as you can see, that after a certain point in time, the accuracy is good. So the accuracy is actually a little more than 71%. But the point is that I told you that we wanted to test our model with different data sets also. We took the average, and one of the good things that we saw was that the model is generalizable. First point. Second point, it is able to handle the bias and the variance. Second point, and the F1 score is also almost similar to the accuracy. So we cannot say that the accuracy is good and the model is not working well. We saw the accuracy, specificity, sensitivity, F1 score. We saw everything. And the point is that F1 score is reliable, and we can see that the F1 score is good. Okay, it is comparable to the accuracy also. Now, the point is that word level and sequence based models we have already seen. USC we have used with forward feature selection. The F1 score we are getting is good, and we wanted to keep the model as simple as possible. Reason is that we want to extend the model to clinical settings. We want to be used in triage. So instead of the model being too complex, we wanted it to be simple so that it can be deployed easily. It is free from bias and variance, and so on. So the point is that, as I told you, that we compared it with Elmo embeddings also. We started this work before sending the paper, but we have seen now that the Elmo is not working well. USC works better. We also wanted to use transformers. Again, we have started this work, but again, my point remains that as far as clinical data is concerned, the number of samples are little less. Again, we are working on the sarin activations. Sarin activations, from my point of view, are important because they are able to reduce the depth of the model. And if we are able to reduce the depth of the model, then it's sort of a good thing. Why it is sort of a good thing is because, again, the number of samples is low, then also the model will be able to learn in a better way. So this is primarily what we did. We are extending the work, as I told you. We are using this work, as in we are using this model for a data obtained from a hospital at Delhi, and see if it works well with other data as well. So thanks a lot.
Yeah. Dr. Basin, a very good job. You have selected a problem statement which many of the technocrats are from getting into this. Since
Thank
I
you, sir.
work in this accessibility domain, I can highlight this particular problem statement is of quite importance.
Thank you.
As you mentioned, ki just because you wanted to have a lightweight model, you started,
Ji.
yeah. Uh, and also you emphasize ki LLMs. Now nowadays LLMs are actually widely used for such
Ji.
use cases. Have you
Absolutely.
tried? Yeah, have you tried Llama model for this?
Sir, the point is that we have not reached that point, but the point is that we tried various LLM models. Our major problem was that the existing LLMs that we have tried are not able to extract the context in very large texts. Why? I'll tell you why. Because okay, the point is that the data that we have got from various hospitals, the number of samples are pretty low. And the
Right,
point is that since I think, because since you are working in this domain, you very well understand that
correct.
that the
Getting the
patterns are
data is a
very, very
yes, yes,
stable. Huh.
correct.
So this is one of the problems that we faced with LLMs. Your
Okay.
suggestion is extremely good. We'll
Like,
also try new LLMs, but the
yeah,
point
what
is
I
that
would
this is what we are saying. Ji,
okay. Continue, sir.
please,
Continue.
please. So the point is that what I was thinking was that we extract an embedding using an LLM. We extract an
Okay.
embedding using use, combine them, and then form the final model. This is what we are planning right now, and this is what we have already started.
Great, sir. Great. Just my suggestion was to compare your results with the existing LLM models, the Llama model
Ji,
I
ji,
am.
ji, ji. So
Yeah.
that we have already started with.
Yeah.
It was a
That's
great
all.
suggestion. Thanks a lot.
Yeah. That's all from my side. Thank you.
Ji.
Thank you.
So anyone else?
Any more questions? Yeah. Thank you, sir. Maybe we
Thank you,
can
sir. Thanks
schedule
a
the
lot.
next presentation. Yeah.
Ji,
Thank you.
Yeah.
ji.
Thank you, Mr. Basan, for your presentation.
Thank you.
I would like to call upon the next presenter, Ms. Anusha R, to present her paper titled CNN-based multilingual voice alert system and traffic sign board recognition. So, over to you, Ms. Anusha.
Yes, ma'am. Can I share my screen?
I'll stop.
Good morning, everyone. So today's topic is the traffic signboard recognition and voice alert system using CNN. So initially, the traffic sign will plays a very important role in the ensuring the road safety because of some drivers may fail to understand or recognize the traffic signboard or because of some language barrier. Our project, traffic signboard recognition and voice alert system using CNN will trained on the GTSRB, that is German traffic sign database. It will classify the traffic sign image onto the 43 classes, and it will process the traffic sign images, and it will also predict the result and display the result with the confidence score, and also it will convert into the multilingual voice alert using the GTTS, that is Google text to speech. So the objectives of our project is to create the intelligent traffic sign system and develop and implement the deep learning model through the CNN. Second one is to give the multilingual voice alert system that we have integrated the Google text to speech, so that we had integrated some of the language to give the alert in different languages. And third is to create the web-based application. We had created the Flask web-based application so that user can upload the image, and the traffic sign will be classified based on what images have been uploaded, and also it will give the voice alert, which should improve the usability and accessibility for the user. Our problem statement is many existing traffic sign recognition depends on the IoT devices or the sensor in vehicle hardware, and it will also make very complex and expensive to implement those kind of things. And also driver may fail to recognize the or understand the traffic sign because of the language barrier, or it may be a lack of attention or the weather forecasting. And we had implemented very lightweight image based traffic sign system so that it will classify the traffic sign without relying on any IoT infrastructure. The system should also provide the multilingual language for the user and it will classify the model and deploy through the web-based application. In the existing system, they had done this project based on the IoT device, and they had used the model like YOLO and RCN and SSD, and also it has been integrated with the IoT devices and also hardware like Raspberry, and also they had a real-time video streaming, and many approaches mainly focus on detecting the accuracy with the limitation attention of the user accessibility. And also existing system doesn't provide multilingual voice alert system. It only provides some of the regional language regional language has implemented. So what we have proposed in our system is it will give the voice alert system in the some of the languages that we have integrated, and also the image is uploaded. It will processed and resized, and it will normalize. Then it will pass into the CNN model what we have trained. The CNN model will classify into 43 classes different sign. We had used German traffic sign board benchmark dataset so that it will predict the class and confidence score and also display the user. It will also enhance the accessibility. The system generate the multilingual voice alert using the Google text to speech, and our solution is the lightweight and doesn't require any IoT device or the vehicle integration. So let us move to how our model will work. We had taken the dataset of German traffic sign dataset, which has a 43 classes. Then we had done an image pre-processing. In the image pre-processing, we had done resizing the image into 32 into 32 pixel, and we have normalized it to the range of 0 to 1. And we have trained the CNN model, that is the feature extraction, and we classify the images based on the traffic sign images. And next we had done the model evaluation. In the model evaluation, we have accuracy, loss, and confusion matrix, and we have saved the saved the TNN model what we have trained. And also we have created the Flask web-based application where the user can upload the any traffic sign image, so that the CNN will predict the what is the traffic sign class and also give the top 3 confidence score. And we had also integrated the multilingual voice alert system, that is Google text to speech. As we see a result, we have a confusion accuracy graph. One is the model accuracy, second one is the model loss. In model accuracy, the training accuracy will detect the basic edges of the traffic sign, as well as the validation accuracy will identify the basic features of the image. In the model accuracy, if the training loss or the validation loss decreases, then the model has been trained. The model has been trained perfectly without having any error in it. In the result, we have a confusion matrix. Here in the confusion matrix, the row will indicate the actual value. The diagonal value will indicate the predicted corrected value, or non-diagonal indicates the non-predicted value of the of the graph. And here we have a result webless fast interface where we upload the image. The user can upload the image, and we have inserted some of the languages, some of the regional languages also. And it will give the output in the form of text, and it will also give audio also, so that user can manually listen to it, what are the alert they are going to give. And we have a top 3 prediction, that is speed limit, top 3 prediction class of the images, how the image is going to classify, and what are the top 3 prediction class distribution. So the conclusion of our project is, it is the machine learning based traffic sign multilingual voice alert system using the convolutional neural network. The CNN model is trained on the German traffic sign, which has a 43 classes. Image pre-processing and CNN architecture contributes the high accuracy performance. The trained model is effectively deployed with the Flask-based application so that user can do the interaction. And multilingual voice alert generation use the Google text-to-speech to improve the accessibility for the user with the languages. So overall, the system is the lightweight, efficient, and user-friendly solution without relying on any IoT devices or vehicle integration. So if we come to future enhancement, our project can be integrated with any of the car branded, so that they can integrate in the car, so that if a user so that if it will helpful for the user to identify the traffic sign. It will identify the traffic sign, and it will provide the guidance in different languages, where a person having any language barrier, it can be helpful to avoid any accidents or misuse of misuse in identifying the traffic sign because of accidents or weather casting, and it also give the alerts in different languages. So this is all about our project. Thank you.
Yeah, Pujita, you have done a lot more work.
Yes, sir.
Well, however, I have few questions about this. As you mentioned, this is a deep learning based approach which uses CNN. Which version of CNN you are using?
It's a convolutional neural network we are using.
How many layers?
43 classes of
That is that is the data. How many layers? How many hidden layers or convolution layers?
That we had.
Okay, fine. You will you present the result graph?
Okay.
No, I would like to see the accuracy and loss in those curves. How much is the accuracy that you have achieved?
It's about 95, sir.
95.
Yeah.
Okay.
Actually, we have three layers. One is a convolutional layer, then we have a pooling layer, one is a fully connected layer. In all these layer, the image pre-processing, how it's going to classify the image, resizing, all those will be happen in this three layers.
Yeah, that was my question, right?
Yeah.
Yeah, in this scenario, which activation function you have used?
Okay, I didn't get, sir.
Activation function. The activation function, yeah, right? Yeah, forget. My question, why don't you try mobile net V2, V3?
So
Since
for
your
that,
since your application, as you mentioned, it is for the mobile phone, right? So
uh,
CNN will be heavy, other than people opt for mobile net.
it's used for traffic sign in the car system. Like we had only we have only done this project for the flash based application. If we do that, if we want to do more about this, then we require some IoT based
Nee,
IoT
nee.
based.
Nee, nee, just I am asking you to replace. Why didn't you try the CNN model named as mobile net V2? Okay, the deep learning model. It's another deep learning model. Maybe later on, if you are not aware, maybe you can explore that. You can try that also. The same data set. Okay, because it is lightweight as compared to CNN.
Yes.
Okay. ठीक है. Couldn't you find any Indian data set?
Indian dataset are not classified. We had taken German dataset because all the images are classified and it also trained dataset. So because of some limited times, we have taken the German dataset. So
Okay. Okay. Thank you.
thank you, sir.
Yeah, that's all. Yeah, organizers, that's all from my side. If there are other questions, audience can ask, or else you can start the next presentation.
So, can I ask something, sir?
Please, sir, please.
जी. So, ma'am, so I have two questions.
Okay.
First is, पहला तो like this asked about the architecture of CNN. Uh, देखिए, as far as I understand, your problem is to see the signboard, ठीक है? By ठीक है, you'll do some object detection, YOLO sort of a thing, extract text out of it, read the text, save it somewhere, and then use Google Text to Voice. Am I right?
Yeah.
So, like, which CNN are you using which is doing all these things? Detecting the object, finding out the text, saving the text somewhere, and then, like, are you getting my point?
No.
It's like, देखिए,
Yeah.
CNN is for classification, which is good. You know, so you have trained model, you have classified, which is excellent. But because I have a problem in that also. But nevertheless, the point is that abhi to dekhe, we have some CNN. As you said, that you have trained some CNN, you have validated some CNN. So first thing was object detection. Might have used YOLO model. Second was extracting text out of it, saving it somewhere. Only then can you use the like Google text to speech conversion, right? है ना? So
We
like this
have
is not clear to me. First point, and there's another point, ma'am. Uh, can you just they can just please see your results section?
yeah, like
So there's something very interesting.
Hmm.
I think Prasanna sir might have also seen this. In your result section, देखिए पहली बात तो you've used accuracy, right?
yeah,
So interestingly, your validation accuracy is more than your training accuracy.
yeah,
Generally, we don't get such things. Am I right, sir?
Yes, sir. Yes, sir.
So, like, ठीक है, you might have done a very good work. I totally understand. Since you are a student, anything that you have done is extremely good.
Yes,
So
sir.
there are
Yes, sir.
some of the things, है ना, which you might want to see later on. Thank you.
Thank you.
thank you.
तुम्हें सब चैलेंज क्यों आपको दिखा? थैंक यू फॉर योर प्रेजेंटेशन.
Yeah, that's all. We can schedule the next presentation.
Yeah, hello, am I audible? Hello.
Hello.
Yeah, am I audible?
Yes, yes,
Yeah, yeah. Now
you're
you're
audible.
audible.
Yeah. Okay, so we can move on to the next presenter.
Please, please.
Miss Ma'am Anamika Sani ma'am to present her paper titled Comparative Analysis of Video Sonography Techniques Used for Hiding Image. Over to you, Ms. Sani.
Okay, ma'am. Should I allow to share my screen, ma'am?
Please, Shirala, please stop.
Yes, ma'am. Okay, good morning to all of you. I'm here to present my paper titled Comparative Analysis of Video Steganography Techniques Using Hiding Image. And from starting, I have to tell about steganography is a secure communication in which we have to hide something in the form of audio, video, or anything else. Any data type of data I can hide in image and video, and different type of steganography techniques can be used. And the various techniques I can use and study. And for the parameters, I have used in this paper PSNR, MSE, and RMSE, which are peak signal to noise ratio and mean square ratio and root mean square ratio also. The analysis is based upon capability and robustness of the video steganography. The objective of the paper is I have done the comparison of different 7 methods in which I have used the basic LSB method firstly, and after that the methods are extended to parity based and RPS method and the other methods also. And the main objective is to find out accuracy and the interceptability and the robustness and the security of the different type of data sets, in which I am using a goldfish image to hide inside the video file. Okay, and to analysis quantitative performances are based upon PSNR, MSE, and RMSE, which I have already told. The methods I have overviewed is LSB method. I think it is the most used and most popular method when we are talking about steganography techniques. After that, even parity, odd parity, Braille method. I can brief it out that LSB method we are using least significant bit to hide the pixel of the image in the video file, and even parity method we are using the number of ones and number of zeros to find out where I have to hide my data of the pixel in the form of image or in the form of any format. But in this paper, I have used image. Braille plus LSB, in which we have used 6 dots to represent the location of the frames, or we can say pixels, and Huffman coding, in which we are going to make the Huffman tree firstly. On based upon the Huffman tree, we are going to select the pixels, and after selecting the pixels, we are going to hide our image pixels. RPS method plus LSB, in which we are going to select the pixels randomly, because in LSB, in even parity, odd parity, we have not the randomness. We have the simple pattern based, we can say, methods to follow. But in a random pixel method, we have used the randomly chosen pixels from the video files. And last one is adaptive LSB method, that is the extended version of LSB, in which we are dynamically select the location for the pixel method. This is my comparison table, in which I have just generalized the advantage and disadvantages of these methods. Even parity, odd parity, LSB, the advantages are as simple as that. The simple is it is LSB method is a simple to implement, high embedding capacity, low visual distortion and all. Same with the even parity, odd parity. The we can say the major difference between these methods are LSB is using least significant bit, then even parity may we are going to choose whether number of zeros and ones according to the given number of even and odd, we are going to select the pixels. These are the advantages of the remaining methods of Braille LSB. All the methods are combined in the LSB method, because we are studying and generalizing the combination of hybrid methods in the steganography technique. And these are the last advantages and disadvantages of adaptive. All the techniques having some disadvantages, as you can see. In some methods, we are going to have the highly stagnalysis, lower embedding capacity because of even parity, and same with the odd parity, capacity limited to the block size. And in the Braille methods, the major problem in Braille method is that we have selected 6 dots to hide the data, and that's why there is a higher pixel modification when we are talking about hiding an image in a video file. And in Huffman coding, the compression overhead is there, because we have to make a tree firstly, and after making that tree, we have to select the pixels to hide the image pixels values. And after when we are going to extract that algorithm, we have to given the overhead information of the tree also in the coding part, so that makes it very complex. And in RPS method, we uses secret key management, because RPS is using random selection now. So in extraction process, we have to give the selection secret key. So that's why these are some advantages as well as disadvantages of the readable methods. For experimental setup, I have used UCF 101 human action recognized dataset. I have chosen this because firstly, these are the realistic videos, and in this dataset, I have 13,000 plus videos I have taken and chosen. But from these 13,000 videos, I have chosen just 134 videos to show the exact outcome, and it was from the category of biking. The dataset is having 100 plus categories of different action categories like biking and gaming and all the videos are having different formats and as well as different sizes, so I can easily find out what and where are the changes are come when I am going to use it, or when I am choosing some method to hide the image in the video file. And the goldfish image is a standard image that is used in recent research papers also, when we are going to use the hiding image method in the stepdiagram part. And for software environment, I have used Jupyter Notebook. Performance matrices I have measured by using PSNR, MSc, and RMSc. These are the basic, I think, analysis, or we can say comparison parameters when we are going to use steganography uh, as a as a secure communication. And PSNR, we need PSNR to high. If 40 plus PSNR we are having, then I can say this method is having good to good quality, or we can say good good hiding method of any type of steganography. And in MSc and RMSc, we have to see that the ratio will be minimum. These are my results when I am choosing the methods to implement in Jupyter Notebook. And these are the results of biking category only, in which we have, I think, 134 videos to hide and goldfish image. And as we can see, all the methods when I implemented with the combination of LSB method, then the PSNR value is having maximum in RPS method. Is that the reason behind is because RPS method is giving me the randomness to choose the pixels from different locations. In LSB we have the fixed pattern. In even and odd pattern we have fixed pattern. In Braille we have we can say we have the disadvantage of having 6 dots to convert, and after that the coding is done. And in Huffman coding, the tree coding part is very high. The extraction process is taken very much time to extracting the results. So in all the comparative, when I have these all are existing results, I have not introduced any new technique here. But I have done the RPS selection method with the combination of different other methods also to achieve maximum or more PSNR value. This is the graphical representation of the results, in which we can see the RPS is showing very good results. The conclusion is that the LSB method outcomes all the techniques, and the PSNR values is showing maximum in RPS method and lower in RMSC as well as MSc in the Stego video. And if I am talking about even parity and odd parity, then they are also showing me the good results, and we have good strong performance also. But when we are talking about the exact PSNR and overall study, then RPS is having more accurate results. And when we are talking about applications of steganography where we can use, then it is all we know that in the confidential data, because of secure medium, when we want that user don't know about the any other person to see any of the data is hiding inside that individual file, then in this type of area we can use the video steganography. And in the future scope, we can combine it with the AI in the machine learning, and in the medical imaging also we can use this type of steganography techniques to hide the individual, or you can say secure data. And hybrid steganography techniques, RPS improves the results, but it is only tested with the LSB method. When we're talking about the other methods, we can combine it with different type of encryption techniques also to secure it and give the more accurate results as compared to the other methods also. And I have already implemented a novel technique in based upon this data set, and in which I have chosen multidirectional method with the RPS method, and that is also showing me the good results. But it is not tested on the different all other videos except biking. So the process is going on, and after that the results will be achieved soon. Thank you. That's it from my side.
Have you tried any recent steganography, video steganography technique? Because this RPS and all.
Yeah, RPS and all are the old techniques, I know. I am
Yeah.
starting with the basic techniques just now. The different new techniques हैं, so वो encryption keys or encryption based techniques are used. So I am trying to implement them also. Recently I just implemented these for comparative analysis so that I can compare with the old techniques with the existing data set that is used in recent research.
Okay. That's all. Thank you.
Thank you. Thank you so much, sir.
Thank you, ma'am, for your presentation. Now we can move on to our next presenter, T.A. Alfina Baledi, ma'am, to present her paper titled Comprehensive Comparative Analysis of CNN Architectures for Wildlife Prediction Using Satellite Imagery. Over to you, ma'am.
Yeah. Hi, good morning. Can I present my
You
screen?
can share the screen. My share.
Okay. So hi, am I audible? So everybody.
Yes, you're audible.
Yeah. Okay.
Yes.
So hi, good morning. I'm Alfina. So I'm here to present my paper on the title Wildfire Prediction Using Machine Learning Algorithms. So this work is basically about the wildfire prediction and detection. So traditionally, wildfires were driven by mostly natural causes, but today it's mainly caused due to the human activity and climate changes. So these both have has become a very major factor in most of the wildfire occurrences. For example, we can take the Palisades wildfire, which happened last year in the California region at Los Angeles. So every year, due to this, it destroys the ecosystems, releases massive CO2 amounts, and damages the infrastructure, which leads to financial things and losses. So the problem statement, uh, yeah. So the problem statement here for our project is the major problem is not just the wildfire occurrence, but it's also due to the delayed detection. So existing systems mostly detect fires only after they occur. So it causes damage, which is irreversible. So, and most importantly, the remote and forest regions are especially vulnerable due to the limited resources there. And the current prediction models also struggle with the accuracy and as well as the regional adaptability. So there's in path for like a need for a proactive, accurate wildfire susceptibility prediction system. So that's why we went along with this. So the motivation for our project is it comes from the increasingly global impact of wildfires and the limitations of current management systems. And early prediction, they can significantly reduce the damage and loss of life as well as the infrastructure. And our main objective is to build an AI-based wildfire prediction models using satellite imagery for scalability and as well as to identify research gaps and to propose a real-time, scalable early warning solution. So here the abstract is here in this work we propose a CNN based wildfire susceptibility prediction system using satellite images. So here the model classifies the regions as wildfire prone or
Maybe you
not.
can go to the implementation part. You talked about
Okay.
this. Yeah. Literature review, the findings of
Literature survey?
literature review, that's fine. That you can explain.
Okay. So for literature survey, we took about 25 papers and we reviewed only recent works from like 2020 to 2025. It mostly covers CNNs and YOLO-based detection, ensemble models, and UAV systems and all those things. And while many of the methods like which they implemented achieved high accuracy, most of the papers focus on fire detection. There's really a scarce number of papers for prediction. So most of the papers they detect after the occurrence and which required real-time video data, and it also lacked regional generalization and so on. So how does our work differ is we focus on pre-fire susceptibility prediction using static satellite imagery. So and the existing systems, they perform mainly binary fire or smoke detection after wildfire occurrence, and they often rely on pre-trained CNNs and generalized datasets, which limits regional accuracy. So most importantly, they lack predictive capability for identifying high risk zones before fire outbreaks. So that's one of the advantages in our project. And our proposed system, it aims to predict the wildfire susceptibility before occurrence. So we used satellite imagery and advanced CNN models to classify regions as high risk and low risk. And by avoiding complex environmental factors such as like vegetation indexes and all those, we didn't use any of them. So we mainly focused on the image-based learning so that the system becomes simpler, scalable, and suitable for implementation in real scenarios. So the advantages for our project is it's mainly the proactive intervention and risk management. And we use the CNN models, which are highly accurate, and it also handles data imbalance perfectly. And the main advantage of our system is that it's being scalable and it's easy for implementation for real scenarios. And it also improves the region specific predictions based on the local relevance and precision. So this is our proposed system architecture. So what we did was we took the publicly available data set, and in the data set we found two sets, like the no wildfire set and the wildfire. And the data set which we found, the images, the data set contains satellite images, and those satellite images were taken using the Mapbox app, which is mainly used for images, heat maps, and all those things. And then we pre-process the dataset. We split the dataset into three: training, testing, and validation. And the dataset contained some truncated images, so we dumped them. And then since CNNs requires these image sizes to be same to process easily, we resized the images, all the images to the same size. And also we normalized the pixel values so that the model can generalize well. And we used five models. We basically done comparative analysis. So we use the five models: ResNet, DenseNet, EfficientNet, and this custom weighted ensemble is the combination of all three. And the simple ensemble is just the ResNet and the DenseNet. It's a combination of those two. So, and then we trained all the models for exactly 10 epochs. And then the best CNN model, the high accuracy was like the DenseNet. So among all, and then for testing, again we used the test dataset. And as for the visualization process, we used the GradCam visualization, which basically generates heat maps. And we did the evaluation, and again the visualization and the error interpretation part. So here the dataset source was the region for the data set which was taken is Canada, and the data set description is this. It specifically shows the regions of Canada, and wildfire, we took 22,710 images, and no wildfires 20K images. And yeah, the data division was exactly 70 by 15 and 15 for training, validation, and testing, respectively. So as for like this were our data set structure and so, and this is the example of the satellite image from our dataset. So in the no wildfire image, the green parts, as you can see, and the wildfire image is slightly a bit like the dark patches represents the fire, and then yeah, this is what I said before. Like the ensemble model is the combination of densenet and resnet, and the custom weighted is the combination of three. So
Yeah, maybe
this
go to the next slide.
okay. So this was the thing which we implemented is GradCam visualization. So it's gradient weighted class activation mapping. So this was the visual explanation method which we used for the CNN based models. So it produces heat maps that highlights the image regions based on whether there's a fire or not. So, and then it also helps verify model interpretability and build trust. So here, how it works is it computes the gradients of the predicted class with respect to the CNN layers output, and it also generates the maps based on weights for each feature, and combined weighted feature maps and combines weighted feature maps into a class discriminative heat map. Like at the end, the thing which we get is after combining all the weights and assessing all the features, it generates a final heat map. And yeah, this is the output. So the image which we used for the for the processing is the no wildfire image for just one process, and the denseness with the high accuracy gave the correct prediction. And since the DenseNet, ResNet, and Ensemble was the top models with the high accuracy, so these three generalized correctly. But the custom weighted fell back with the accuracy a bit, so it didn't generalize properly. And the efficient net was the least performing model, so it predicted as wildfire, which is a wrong prediction. And then for performance analysis, we used these 6 metrics. And this is the evaluation metrics table. So here, as you can see, for the accuracy, the ensemble, DenseNet, and ResNet, for all these three, we got 0.98, the highest accuracy. And
Here, a little more.
sorry?
Yeah, I just wanted to give you a reminder that your time is coming to an end. Your time is coming to an end, so can you just speed up the presentation?
Okay, sure. So this is the evaluation metrics. So for the ensemble DenseNet and ResNet, we got the highest accuracy, and weighted since the combination contained the efficient net, it gone down very badly. And for efficient net, it's 0.59, which is really low. And as for the error interpretation, and we use the confusion matrix. So here, the x-axis contains the predicted values, and the actual side contains the actual values. So
Yeah,
here,
yeah, Alfina, maybe you can
okay,
go to the conclusion part.
okay.
We got, yeah.
So the thing which we achieved is we successfully developed a deep learning based system to predict the susceptibility from satellite images, and we implemented various CNN architectures and compared them to find the best one. So out of all, we found that the DenseNet performed the best. And then we also used for better interpretability, we used GradCam visualizations. And at the end, we came to a conclusion that the DenseNet-based approach was the strong potential, has the strong potential for supporting the early wildfire risk assessment.
Yeah.
Thank you.
Yeah, done a pretty
Yeah,
good amount of
and
job. Yeah, I appreciate your efforts.
okay.
I have few questions about this.
Yeah, sure.
Yeah, you mentioned that DenseNet gave the best performance out as compared to the other one. But if I look at the results, what you presented,
Uh,
uh, the accuracy and the F1 score for all these methods was same. DenseNet,
um,
efficient, yeah, ResNet,
yeah,
and Ensemble,
DenseNet. Yeah,
0.98. Whether this is a training accuracy or validation or testing accuracy, because you have these three different sets, right?
yeah. No,
Oh,
this was performed on the testing data set actually, because that's the thing we need to use, right?
is it testing accuracy?
Yeah.
What about the training accuracy and all?
Training. Um.
Okay, great. If this
Okay.
is the testing accuracy, then it's a these results are quite good. I'm skeptical
Yeah,
about this.
and
Yeah,
actually,
maybe you can.
we were also skeptical about this. So what we did was to check the actual robustness of the model. We added noise to the data set and we tried various methods to check if the model is really generalizing well or if it's just overfitting.
Yeah.
But even after we tried all that, we got this same results. So we were
What?
sure that it was properly performing without the improper things.
Yeah. Uh, so maybe what you can do, you can plot those graphs for training, testing accuracy on the same plot, and that way you can present the results in a better fashion. Yeah,
Okay.
great. What was the size of the image? You said you resize the images. What was the size that you have chosen?
Um, Size of the image, the final size we were asking, the all for all the images, right?
Yeah, yeah, because
I resized them to 350 pixels, like each, because they were varying for each pictures. So yeah.
what was the reason for resizing it to 350 pixels?
Sorry.
Why did you select that particular size? What was the reason?
Uh, I
Usually,
am not sure why, but basically I
okay,
resized it because the CNN has to like
yeah,
process it like because it
correct,
requires equal sized
correct.
images.
So usually recommended size is around 224, not more than
Oh,
255 or 255.
okay. I'll just take a note of it.
Okay, great.
224.
Yeah, that's all from my side. Yeah,
Okay.
Alfina, good. Keep it up. Fine.
Yeah. Thank you.
So, can I ask something?
Yeah, sure. Go ahead.
Gee, thank you. So, great work. Just two small questions. So,
Yeah.
first is that matlab, we have the comparison of model evaluation matrix in front of us.
Yeah.
So, as Sir rightly pointed out, if you see the ensemble and the DenseNet, they are exactly same.
Yeah.
0.79798, 9798, 9798. But you
Yeah.
say that DenseNet is performing better. Second point that we saw the confusion matrices. The confusion matrices
Okay.
for ResNet and DenseNet are same. Still, DenseNet is performing better was a little difficult to understand. Please see
Okay.
the second row of the weighted model. So it says
Okay.
zero for all, which is matlab Prasanna sir will sir like so this is a little strange for us sort of a thing.
Okay.
So zero for all precision recall F1 score, zero for a particular model is like any case, everything is good. So there are some of the things in the data which is not very clear to me. And one more thing
Okay.
that the whole premise of the your work was that generally people use images so they classify whether there's a fire or not. And you wanted
Yeah.
to find out the probability if it is susceptible to fire. Am I right? So
Sorry.
by that logic, what you said earlier in your opening remark was that most of the models are classifying whether there's a fire or not, right?
Yeah.
And you are trying to predict if there's a probability of fire, right?
Yeah.
which is excellent, which is a very, very pertinent problem. The
Okay.
only thing is that for that you should have a particular database, right? So, like
Yeah.
any database gives you the leverage of like there is no fire, and before the fire you have some data to observe. Like, did you really get that data? And in the
Yeah.
now like in both these data sets, do we have the privilege of finding out, like extracting that particular data? So two small questions. Baki to
Okay.
like you must have done great.
Yeah. I understand the question actually. Yeah. Um.
Yeah, maybe
Thank you. Thank you.
you can. Hello, Alfina.
Yeah, I can
Since the
hear you.
research is continuous process, so maybe you can pay attention to these questions and proceed with your research in that direction. Yeah,
Yeah,
that's all
sure.
from my side. Yeah. Good.
Yeah. Okay.
Gayatri ma'am, can we have the next presentation, please?
Yeah.
Yes,
Thank you.
the presentation. I'd like to call upon our next presenter, Ms. Irene Sarah Thomas, to present her paper titled Demographic Bias and Deepfake Detection, Systematic Review of Framework for Indian Research. Over to you. Hello, ma'am. Are you present?
Yes, is my screen visible?
Uh, just a second.
Is it?
It's visible. Kindly audible. You can.
Yeah, I hope it's visible. Is it?
Yeah, it's visible.
Okay, thank you. Good morning, everyone. Today I'm presenting our systematic review examining demographic bias in deepfake detection systems with a particular focus on developing a research framework for the Indian context. This has been a collaborative work from my university, Christ University's Department of Statistics and Data Science. So, we conducted a Prisma guided systematic review analyzing 87 peer reviewed studies that were published between 2019 and 2025. So our findings they revealed major critical gaps in the current research, and we have decided to propose an evidence-based path forward. So deepfake technology it uses GANs and autoencoders to create synthetic media that manipulate faces, voices, and personas. So these possess very significant threats to information integrity and democratic processes. However, mounting evidence shows that detection systems they exhibit systematic demographic bias. Now, the precedent is concerning. Bolamwini and Gebru's 2018 gender shade study. It found a commercial facial recognition systems had 34.7% error rates for darker skinned females versus just 0.8% for lighter skinned males, which is almost a 43-fold difference. So since deepfake detection shares underlying architectures and training data sets with facial recognition, we hypothesize that similar biases exist in almost all data sets available. So we followed the Prisma guidelines to ensure transparency and reproducibility. We searched five major databases: IEEE Explore, ACM Digital Library, Science Direct, Springer Link, and Archive. So the initial search it yielded almost 1,327 papers. After deduplication, which reduced to 1,095 unique papers, then two independent reviewers screened titles and abstracts with high agreement, coherence k equal to 0.84, narrowing it down to 215 papers. So the full text review with k is equal to zero point 0.8 resulted in a final 87 included studies. So quality assessment used adapted Newcastle Ottawa scale, where the median score was 7 out of 9. Now, our analysis it reveals a severe geographic concentration in the deepfake detection research. Like 82% of all studies, that is 71 out of 87 studies conducted, originate from either North America or Western Europe. East Asia, it contributes just 13%, while all other regions combined account for only 6%. Now, this is problematic because like populations from Africa, South Asia, Southeast Asia, and Latin America, they collectively represent over 60% of the global population, but remain substantially understudied. There are no enough data sets with images that include or that are inclusive. So data set demographics, they kind of mirror this balance, like Phase Forensics plus plus, which is one of the most widely used benchmarks. It contains approximately 69% Caucasian faces, that is whites. And South Asian representation ranges only 2 to 5% across all major data sets, despite the fact that South Asians comprise over 20% of the global population. Now, the second gap revealed was that only 21% of the studies, that is just 18 out of the 87 papers reviewed, conducted explicit fairness evaluations using the established metrics. Now, among these, statistical parity was the most common at 44%, despite being conceptually inappropriate for detection applications. Only three studies, they justified their metric selection based on deployment context. Now, the third gap revealed was that only 15% proposed mitigation strategies, and merely 7%, that is just 6 studies out of the 87, they provided empirical validation. So the performance disparities are pretty substantial. That is, there is up to 10.7% error rate variation between the demographic groups. The intersection analysis also revealed that there was a 17 percentage point accuracy differences between lighter skinned males, that is 94.2%, and darker skinned females, 77.1%. Now, while no published studies are directly measuring deepfake detection bias for Indian population, the related research, they establish a very concerning baseline. Like Jain and Pashira's 2021 audit, they examined 4 commercial facial processing tools on 32,184 Indian faces. Phase plus plus, they exhibited a 14.68% gender classification error for Indian females versus just 0.26% for males, which is a 56-fold gender disparity within the Indian population alone. And which is even more alarming is that this 14.68% error for Indian women is 5.9 times higher than the 2.5% error rate Bolamini and Gebru documented for African women using the identical phase plus plus system. Now, India matters. There are 1.4 billion people. There are 25 plus ethnic groups, 22 official languages, and continuous phenotypic variation that doesn't fit Western categorical frameworks. Now, the good news is that India has progressed from these 0 relevant data sets in 2020 to 3 substantial data sets by 2025. One is the DF platter, which was made by IIT Jodhpur in 2023. It is a primary data set with almost 133,260 videos, 454 Indian subjects, and they have balanced gender, Fitzpatrick skin tone annotations, and cultural occlusion labels. In the phase 2024, they have added 101 videos with exclusively Indian subjects. And Index Side Phase 2025, they address the side phase detection with diverse pose angles. Now, however, despite all this infrastructure progress, systematic fairness audits still remain unpublished. No studies are there that quantify performance disparities, examining intersectional bias, validating mitigation strategies, or assessing deployment in realistic Indian contexts. Now, the question arises that why do Indian women experience 14.68% error rates? Now, there are 6 technical mechanisms that explain this. First is insufficient training data. Indian faces, they comprise less than 5% of the major data sets versus 8 to 12% for African faces. Now, the second reason is India's continuous phenotypic variation, like from 4 major ancestral populations, it doesn't fit the discrete algorithmic categories that were designed for Western population. Now, the third reason is cultural markers like bindis, diverse jewelry, and religious grooming appear nowhere in ImageNet or VGG face, which confuse the Western trade systems. Transfer learning propagates these biases. Adversarial training in GANs, they miss these demographic specific artifacts, and infrastructure constraints mean artifacts behave differently under real world Indian conditions. Now, what have we proposed? Like, we propose a systematic four-phase research program that leverages the existing Indian data sets. Now, phase one, that accounts for months 0 to 12, that is almost a year. We will be conducting comprehensive fairness auditing, that is evaluating five representative architectures on DF platter with equalized odds as the primary metric and intersection analysis. Phase two would be from months 12 to 18, like mitigation validation, test data centric, and model centric approaches with three-stage evaluation targeting the equalized odds below 0.10. Phase three would be months from 18 to 24. We would be developing intersectional framework, examining how biases compound at demographic intersections. And phase four, that is 24, that is after 2 years, pilot development with fact checking organizations and real time monitoring and independent oversight. So, to conclude, our review of 87 studies, it revealed a clear pattern, that is 82% is Western concentration, 21% minimal fairness evaluation, and 7% almost no validated solutions. So, it is a big deal that India has made progress from zero data sets in 2020 to three by 2025, but zero systematic fairness audits have been published. Meanwhile, Indian women face 14.68% error rates, nearly six times what other populations experience. We now have the infrastructure, that is, we have the three data sets, DF platter, Indi phase, and Indic side phase, to address these gaps systematically. The four-phase framework provides a roadmap to measure, validate, understand, and deploy fair deepfake detection. Now, whether these systems amplify existing inequalities or help them reduce them depends on the choices being made now by researchers, institutions, and policymakers. So, thank you.
Yeah, thank you. Mm, you highlighted the error rate related to deepfake on Indian women. It's a
Yes.
pretty important aspect, important research in this particular era. And
Yeah.
you highlighted these three data sets, phase data set and other two.
DF platter. Yeah.
Yeah.
And
So
yeah.
in this sense, what do you think in the near future this error rate will be reduced or
Okay. In order to conduct this research, we do require access to these data sets. So, which is
so is it
extremely
not
difficult.
available? Okay.
It's not easily accessible. The issue arises, like, in order to correctly classify people, in order to correctly classify, like, when it comes to Indian women, we need enough training data, which is unavailable at
Correct.
the moment. Yeah, because accessibility, there are privacy issues that are attributed to it. So, in the coming future, we can hope that we get, depending on the training data that we get, we will be able to train the models much better in order to classify Indian women. And it's not just the Indianness of classifying them as Indian. I'm looking into, how do we say, like, when it comes to India, there are people from the four corners of India, they look entirely different. And
Right.
that is what we are aiming for. Like,
Okay.
inclusivity matters. The people in the south do not look anything like the people at north. So that
Yeah.
is what we are aiming at. So it's not just women. So we do hope that we solve this issue for women as well as people from all corners of India. So yeah.
So which models you have tested? Say you presented the statistics
Um,
around 14 to
yes.
16% error in the. So what were the models
Yes.
that you have used?
I used EfficientNet. That is actually the only model that I used. Due to resource shortcomings, I could only use EfficientNet. So that is the model that I've used.
Okay. Any LLM model and maybe the GPTs, the commercially available
No, no,
GPTs? Okay.
no.
Yeah, I appreciate your presentation slides. Which AI tool you have used? Just for my knowledge, just I'm
Uh,
asking.
okay, I primarily use GenSpark, and followed by I used Google Slides as well, which actually accentuated the slides a little more. So yeah.
Thank you so much. Yeah.
You're welcome. Thank you.
Thank you for presenting, ma'am. I would like to call on our next presenter, K. Srivalli, ma'am, to present her paper titled Non-Invasive Protection of Diabetic Ketoacidosis using PESMA. Ma'am, are you available?
May I allow to share my screen?
Yeah, sure. You can
Yes,
share.
please. Yes.
Good morning, everyone. I will begin by briefly introducing my work on a non-invasive method for detecting diabetic ketoacidosis using breath analysis. This work focuses on developing a low-cost and portable healthcare solution suitable for real-time monitoring. Coming to the introduction, diabetic ketoacidosis is a serious medical condition that occurs mainly in diabetic patients due to insufficient insulin. When insulin levels drop, the body produces excess ketones, which can become life-threatening if not detected early. Current diagnostic methods mainly depend on blood or urine tests, which are invasive and uncomfortable for patients. Next, the motivation. The motivation behind this work is to avoid painful blood testing methods. Research shows that acetone concentration in human breath increases significantly during DKA. Since breath analysis is simple and painless, it can be used as an alternative diagnostic approach, especially for frequent monitoring and early warning. Uh, Coming to the literature survey, several studies have confirmed that pre-acetone is a strong biomarker for diabetic conditions. Many researchers have used metal oxide gas sensors and embedded systems for detection. However, most existing systems are expensive, complex, and not suitable for continuous monitoring, which motivated us to design a simpler and affordable system. And coming to the proposed method, our proposal method detects acetone levels through the VOC sensing, that is volatile organic compound sensing. We use an MQ7 gas sensor connected to an ESP32 microcontroller. Based on the detected concentration, the system categorizes the conditions into normal, moderate, or abnormal, and provides an instant feedback to the user. And this is the block diagram. And coming to the block diagram explanation, the block diagram explains the overall flow of the system.
Your
The
slides are not changing.
No, sir.
Hello.
Yes,
We
sir.
are
Slides are not changing, ma'am. It's from introduction.
For me, it is appearing, ma'am.
Yeah, ma'am. Then do one thing, unshare it and share the entire screen rather than sharing the presentation on all.
Once I will stop and I will again share it, sir. Now appearing, sir. Now my screen is visible, sir.
Yes, visible now. You can continue.
Hello, ma'am. My screen is visible, ma'am.
Yes, visible.
Yes, ma'am. Coming to my block diagram explanation, the block diagram explains the overall flow of the system. The breath sample is introduced into a control chamber where the gas sensor detects VOC levels. The ESP32 processes the signal, applies classification logic, and sends the output to the display and alerts the units. Next, coming to the hardware components, the ESP32 acts as the brain of the system and handles the data processing. The MQ7, it is the MQ7 sensor. The MQ7 sensor is responsible for detecting the acetone related to the VOCs, and the LCD display, which shows the real-time values, while the buzzer, it provides an alert when an abnormal conditions are detected. All components are chosen to keep the system very compact and economical. Next, coming to the methodology. For safety and ethical reasons, real patient breath samples were not used. Instead, we used simulated samples such as normal air, sanitizer vapors, and perfume vapors to represent the different acetone levels. The sensor output is processed and compared with the predefined threshold to determine the decay levels. And this is the working procedure. When the system is powered on, the sensor continuously monitors the VOC levels. The ESP32 reads and converts these values into the meaningful data. Once the acetone level crosses a certain limit, the system automatically identifies the condition and it generates a visual and an audio alert. Coming to the results, the system was tested under the controlled conditions using simulated samples. The results shows a clear differentiation between normal, moderate, and abnormal levels. The classification was consistent and repeatable, indicating a stable sensor performance and reliable system behavior. Next, coming to the advantages and limitations. One major advantage of the system is that it is completely non-invasive and easy to use. It is cost-effective and suitable for rural healthcare environments. However, since MQ7 sensors are sensitive to the multiple VOCs, cross-sensitivity is a limitation. Also, a clinical validation is using real patient samples are required. Coming to the conclusion and the future scope. In conclusion, this work demonstrates the feasibility of using a breath VOC analysis for early decay detection. The proposed system provides fast and painless monitoring. In the future, accuracy can be improved by using advanced sensors, machine learning techniques, and IoT-based cloud monitoring for real-time healthcare applications. Thank you.
Sir, do you have any questions?
No questions, ma'am. Maybe we can go to
Okay. Yeah, okay. Thank you, ma'am, for your presentation.
Ma'am, with your permission, may I leave the session? I am having interview at 11:30, ma'am.
Yeah, no questions. Thank you for your presentation. Now I'd like to call upon our next presenter, Thodeti Navya ma'am, to present her paper titled Performance Analysis of OTFS-IM over Generalized Alpha Mu and Kappa Mu Feeding Channels with Perfect and Imperfect CSI. Over to you, ma'am.
Yeah, hello. Is my screen is visible, ma'am?
Yes, it's visible. Please go ahead.
Yes, it's visible.
Yeah, good morning all. And my paper title is Performance Analysis of OTFS IM over Generalized Alpha Mu and K Mu Fading Channels, and also including with the perfect and imperfect CSI. Coming to the introduction, the motivation behind this OTFS system is in a in this higher mobility wireless communications, there may be a lot of rapid fluctuations while the vehicular and high speed train environments. Since there are more fading will be possible while the vehicle moves or train moves with a higher speed. So uh, like already existed system like OFDM, it actually suffers in high mobility environments because of the only considering the frequency domain, and with and it may cause like intercarrier interference. So we are moving to the OTFS, in which we will form a grid of a delay Doppler, so that the
performance will be robust due to the considering of a 2D domain, like the delay and Doppler, that is related to the time and frequency. And although OTFS performs better than OFDM, it lacks at the spectral efficiency because of the transmission of the less bits. So for that spectral efficiency, we are going for an index modulation, so that the spectral efficiency will increase. And coming to the related works, this is an orthogonal time frequency space with the improved index modulation. And in this, we can introduce some technologies like memo, and also we can go for other index modulations. I mean, we can change the modulation techniques due to our certainty or our suitability for the system. And the next one is generalized dual mode index modulations, in which this index modulation we can use two different modulation techniques, so that the efficiency will be more. And also we can use detectors like ML and LLR detectors at the end of the receiver, so that it robust the performance of the BER. And it is Doppler diversity reception of OTFS modulation, and this is a basic one, like how the OTFS modulation will be occurred in higher mobility systems. Coming to the methodology, here we will generate an input bit stream, and then we will apply the index modulation concept, like how many bits needs to be activated in a grid. For example, if there is a grid formation of 100%, we will go for like a 40 or 30% of grid activation, so that the energy and power efficiency will be there. So the rest of grid points are off, so that the energy will be used less, so that will become an energy efficiency. And we are using index modulation, so that some bits are selected, some bits are selected to use for the grid, and another bits are used for the modulation, so that at a time we will transmit the more number of bits which are in the grid position. And the general OTFS modulation, it is formed using the ISFFT transform technique, that is symplectic fast Fourier transform technique. In the modulation, we will use inverse of it, because whenever we are forming the grid, we will be in the delay domain Doppler, so we will convert into the time frequency domain, so that the channel will be we can transfer that signal in the channel domain, that is like a fading channel, in which any noise can be added. So it is like we can, in the channel also we can use like channel state of information to stabilize our channel, so that we can know the channel behavior before we transmitting the signal, so that the system will be robust. And after the channel transmission after the signal transmission through the channel, we can do the demodulation process, like the kind of OTFS demodulation, where we will use the simple SFFT transform technique. And at the end, we can use the we can use the detector, so that we can recover the whatever the transmitted bits are there. Yeah, coming to these specifications, the simulation tool I have used is a MATLAB, and this is a like IM based OTFS, not the simply OTFS system. And the modulation scheme has is 64 QAM, because of the to increase the spectral efficiency. So whenever we are going for higher order modulations, the spectral efficiency will be decreased because of the constellation points. The distance will be increased, so that the distance will be decreases between the two constellation points, so that there will be a chance of more BER. But instead of
Maybe you
going,
can go to the next slide.
yeah, coming to the simulation results, the first is like OTFS system that is already existed. Now we are going for a IM OTFS that it can give a better performance than the existed OTFS system. Here I have used a 40% activation of the grid. And this is IM OTFS has implemented over alpha mu and K mu fading channels. Coming to the alpha mu fading channels, whenever the alpha is increased, the alpha means as a non-linearity factor. Whenever the alpha is increased, the linearity will also increases. That means non-linearity decreases, so that the system will be performed very well. And the whenever alpha increases, the amplitude of the signal will be concentrated at a, at one point. And mu is a multipath cluster, so whenever we have in our environment, we will have different multipaths, so that all multipath propagation signals will be added, so that the signal strength will be increased. Coming to the KMU, K is LOS component, line of sight component. Whenever we increase the line of sight component, the performance will be increases. Yeah. This is like alpha mu fading channel. In this, we will take mu as a constant, alpha as varying, and in the second part we will do as alpha as constant, varying the mu. And we can see that the nonlinearity decreases. That means alpha is increasing, so that the performance of BR will increase. And coming to the mu, by increasing the mu, multipath propagation will increases, so that the addition of the signals will be added, those the strength will be increases. So the BR performance also improved while increasing the mu value. And this is the same for the K value. Whenever we increase the K value, that is line of sight component, the performance will be increases by keeping the multipath propagation mu. And the second part is the similar to the alpha mu. Whenever we increase the alpha value, the multipath propagation will increases, so the performance of the BR also increases. And this is introduction of the CSI, channel state information. Here the channel state information is adding some known noise to the channel. So whenever we add noise to the channel, the performance will be degraded. So the higher the noise we added, the worse the BER performance will get. So for epsilon is equal to 0, we will get less less BR, because we haven't added, that is like perfect CSA. And if we increase the epsilon value, that is CSI value, then the noise will be added, so the BR will be degraded, sorry, BR will be increased, though, so performance will be degraded. This is for both alpha mu and K mu channels. Coming to the conclusion, in general, the OTFS will performs well, but according to the spectral efficiency and energy efficiency, the OTFS IM will show the better results. And not only in non-fading channels, it is suitable for other fading channels like alpha mu and K mu. And by introducing the CSA factor, it helps more robust performance to the upcoming generations like 6G, behind 6G. And this work can be extended to the RAS. This OTFS IM can be introduced in RAS systems also, so that the performance will be further enhanced. These are the references. Thank you. Any questions?
So you have mentioned you have simulated this using MATLAB, right?
Yes, sir. Yes, sir.
So here, how many source destination pairs, means the sender and receiver, our connections were considered, or was it a single signal?
No. This is for single only.
Single only. Okay.
Single only.
Because while presenting your statistics, you mentioned about multipath propagation and all, right?
Like
And
I
yeah,
have
yeah,
taken only
yeah, yeah.
SAS.
For the same signal, you are considering the various different fadings and all,
Yes,
right?
sir.
In the very first result, what you presented, this
Yeah,
one.
yeah,
What is the inference or what you draw from here? Actually speaking, the
yeah.
BR, right?
Bit error
Uh,
rate. Yeah.
yeah, but if you can see for OTFS, right? It is the
Yes.
least uh, signal to noise ratio of 25 dBs.
Yes,
You
sir.
don't have any statistics for IMOTFS.
That is like we can increase the number of frames. I mean, we can increase the number of bits so that it will also calculate according to the bits. Like,
Correct. So if I see here when the SNR is improved, right?
yeah.
OTFS performance is poor as compared to OTFS,
Yes, sir.
right?
Yeah, yeah.
Okay. Does the literature mention this?
Like, I mean,
The means for the higher signal to noise ratios, OTFS is much better than IMOTFS.
yeah, yeah, yeah.
Okay.
It depends on the whatever the modulation we have used and the number of bits we have
No,
used.
this is generic. No, here on
Yeah.
the first slide, right? You did
Huh.
not mention about any modulation. This is
Okay.
64 QAM signal, right?
Huh.
So if you look at these graphs, this IMOTFS, right? Its signal bit error rate is 10
Yeah.
power less than 10 power minus 4. Whereas for for IMOTFS it is less than 10 power minus 4, and for
Minus.
OTFS is greater than 10 power minus 4.
Huh.
So that means this
IMOTFS
OTFS,
will has less BER compared
yeah,
to the OTFS. Yeah.
okay, 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 that's it. Yeah, go ahead.
Yeah. Thank you, sir.
Thank you, ma'am, for your presentation.
Thank you, sir.
I would like to invite the next presenter, M. Shivaranjani ma'am, to present her paper titled An End-to-End Timer Forecasting Algorithm for Improving Data Transmission Efficiency in Vehicular Networks. Over to you, ma'am.
Yes, thank you. Yes, warm morning to everyone. Myself, M. Shubhranjani, full-time research scholar in the Department of ECE, Congo Engineering College. My paper title is RTO Star, an end-to-end timer forecasting algorithm for improving data transmission efficiency in vehicular networks. Yeah, this is the research agenda for today. Yeah, going to introduction. Vehicular network is an essential component of ITS. It's enable communication among autonomous vehicles. When vehicles are interlinked with the internet via RSU, it directly information can be exchanged from vehicle to cloud servers. It reduces the operational costs of a vehicle diagnostic. For example, from remote location, you can monitor vehicle fuel, tire pressure, or any malfunctions in the vehicle, and then you can rectify it. Yeah, when internet is introduced into the network, the TCP plays an important role because in today's world, 90% of internet protocol uses TCP because it's more reliable and it's trustworthy. For example, for every data transfer, it's wait for an acknowledgement. After successful reception of acknowledgement, it transmits the next data. For that, it uses a concept called RTO, that is a retransmission timer. It is the maximum time the sender has to wait for the acknowledgement. If acknowledgement received within the time, the sender assume it has a successful data transmission and it will transmit the next data. If not, it will identify it as an indication of condition and reduces the transmission rate and then retransmit the same data again. Yeah. In today's world, all the devices are following RFC 6298, which is proposed by Jacobson in the year 1988. The Jacobson uses two variables, that is variance RV and then smoothed delay RISR, to compute the forecasted RTO value. The forecasted RTO is calculated using the above three expressions for every successful reception of acknowledgement. If in the case of congestion, we can't compute RTT value. So in that case, what the Jacobson do is it will blankly multiply the previous RTO and then it will retransmit the same packet for the value of alpha, beta, and k value. From the Jacobson's RFC 6298, they have fixed the value of 1 by 8, beta value is 1 by 4, and k value is 4. So from this, the problem statement is the Jacobson proposed RTO algorithm, it is proposed in the year 1988. It is more suitable for wired environment when it is introduced in a wireless network. So in vehicular network, there may be due to link disconnections may be there. Due to more link disconnection, sudden rerouting will be taken. So in that case, the RFC 6298 won't perform well. So especially in the vehicular environment, more link layer retransmission get taken. This increases the RTT values. So same way, the more furious timeout occurs in vehicular network, the sender takes it as an initiation of congestion and reduces the transmission rate. So the overall the performance of vehicular network get reduced. So the proposed RTO star should reduces the furious timeout and also improve the performance without much changing the RFC algorithm 6298. Yeah, this is a literature paper I have taken for the analysis. The first paper, CCRTO, in this they have tried to modify a minimum RTO value and then K factor. Instead of 4, they have changed the value of 6. In the second paper, ELRTO, they have introduced a new variable that is a spike suppression variable in the RFC 6298. In the hybrid RTO algorithm, they focused more on data reception more than delay. So they have increased the value of timer values more much. Then the next paper is WRTO plus. In this paper, instead of fixing the fixed alpha and beta value, they have computed alpha and beta value for every reception of RTT, and then they have introduced a new variable called neta. So in the CCOP RTO, they have introduced a new variable backup algorithm. So whenever the condition occurs, instead of blankly multiplying the previous timer by 2, they have used some variable factors in it. So from this, what I have analyzed is that when you are fixing the RTO value of constant, more furious timers occur. So when you are fixing the RTO values much higher, means the entry delay increases. So the efficiency of this RTO algorithm, especially in multi-hub vehicular networks, performance is poor. So there is a need for adaptive and contextual RTO estimation. So the proposed RTO should minimize furious timeouts, and it's also optimize the waiting time, and also it improves the end-to-end performance. So the performance, the proposed algorithm should focusing on, it should react to delayed acknowledgement. That is, it should give more additional time for delayed acknowledgement, and also it should reduce the difference between the forecasted RTO value and then actual RTT value. So this will improve the performance in vehicular networks. So when the timer value is higher means the sender will wait for more time even if the acknowledgement get drops. So this will increase the entry and delay. If the timer is more small means frequent timeout occurs. For example, before the acknowledgement reaches the sender, the timer get expired. So the end-to-end performance is reduced. So for this, I have designed the algorithm into 2 stages. The first stage is for first successful reception of acknowledgement, and then remaining successful reception of acknowledgements. For the first state, for first transmission of data packet, I have fixed my timer as RTO value as 1000, and then I will transmit the first data. If the acknowledgement received, it to move forward. If not, it will multiply the timer by 2, and then it will again retransmit the packet. If acknowledgement received, I can compute the RTT value. From that, it will compute SR value and then RB value. From that, it will compute next forecasted RTO value for the next transmission. So in the next transmission, it will fix this timer value and then it will transmit the data. If acknowledgement receives, it will go to stage 2. If not, it will again go to backup algorithm and then multiply the timer by 2 and then again return the same packet. I will explain the stage 2 in next slide. Yes. So for the proposed RTO star algorithm, I have introduced a new variable called delta AS in the RB computations. So I have computed this RB as gamma into previous SR value. So for fixing this gamma value, I have done some analysis. So for this, I have taken 500 samples of real-time vehicular samples. of RTT, and then I have varied this gamma value from 0.025 to 1, and then I have plotted the RTO to RTT deviation value. So in this, the minimum value of RTT deviations are not visible, so that I have restricted this gamma value from 0.025 to 0.1, and then I have analyzed this. So from this, when the value is 1, the deviation is goes exponentially. So this black line shows the actual RTT value, and then this red line shows the actual RFC 6298 value. For if I am fixing this gamma value of 0.05, that is which is denoted in green color, it is better than RFC 6298. Also, it reduces the gives extra time to for the delayed acknowledgement. So for my proposed algorithm, I'm going to fix this gamma value as 0.05 in the previous slide for the stage 2 computation. Yeah. So I'm going to do my analysis in Network Simulator 3, open source tool. So in order to make this simulation more realistic, I have used OpenStreetMap and then Sumo tool. So for this realistic analysis, I have taken the nearest toll gate, that is Vijayamangalam toll gate, which is located in NS554 as a sample location. And then I have cropped 1000 plus 1000 from this OSM map, and then I have fed the input as to Sumo. And then from that, I have generated mobility, and then I have given that mobility to NS3, and then I have analyzed the entire results. This is the simulation parameters of my results. So in order to analyze the proposed algorithm's performance, I have varied the vehicle mobility from 50, 100, 150, 200, and then I have analyzed different metrics like the first one. I have analyzed the number of retransmission packet, that is in this, I have varied the vehicle speed from 50 to 200. When the vehicle speed is slow, means there will be a higher possibility of connection from one vehicle to nearby vehicles. So there will be higher connection, the higher data transmission. There will be less possibility of packet drop. So that is directly goes to less number of retransmitted packet. When the speed is increased, the link mobility, that is link disconnections occur more frequently, which is directly proportional to higher number of packet drops. This indicates the more number of retransmitted packet at 200 km per hour speed. But when you see in the results, the proposed algorithm with additional timer gives more time for the sender to wait for an acknowledgement, and it improves the end-to-end performance, also reduces the packet drop. The next one is a transmission efficiency. That is how many number of packets successfully received to the total
Hello,
transmitted
ma'am.
packets. Yes.
Ma'am, you have reached the 9-minute mark, so can you please speed up the presentation?
Yeah. 1 second.
Yeah.
Yeah, this is transmission efficiency. This also performs power in low speed, and in high speed, the performance gets reduced. The same for throughput, it is number of packet data transmitted per second. At low speed, the performance is high. At high speed, the performance is reduced. Yeah, conclusion. In conclusion, what I have found is that by introducing new variable in the RTO forecasting algorithm, which gives additional time for the delayed acknowledgement and improves the overall performance, which reduces the overall timeouts and increases the entry and throughput than existing algorithm. Yeah, thank you.
Okay. Yeah, ma'am. Yeah. As per my understanding, I guess you have modified the TCP mechanism with your
Yes,
called
sir.
as RTO, right?
Yes, sir. TCP, there is a small part called RTOs, and I have modified this algorithm, RTO algorithm, which is proposed by
Correct.
Jacobson's algorithm. Yes.
Yeah, and that COCO was already proposed by some other researcher.
Yes, sir. These also all algorithms are already proposed.
Okay. Okay. So during your presentation, you highlighted this MAC, right? Transmission, MAC transmission, retransmissions may also be reduced, right? Have you,
Yes, sir.
if there is some provision which makes that MAC retransmissions lesser, will this improvise your result?
So actually, I'm focusing on a condition control algorithm, sir.
Yeah,
So in order to boost the
I
condition,
understood
yes,
you.
sir.
I
Yes, sir.
understood.
Yes, sir.
You are working at the transport layer. Yeah,
Yes,
I
sir.
do
Yes, sir.
agree.
Yeah.
Just my question, if some provisions are being made at the MAC as well, will
Yes,
it
sir.
further improvise?
Yes, sir. So MAC layer retransmissions can be on nearby hops, sir. So if the connectivity is more higher or waiting time is more higher at the MAC layer, means this can be improved, sir.
Right.
Packet drops can be reduced, yes.
And here in this scenario, you have considered only the infrastructure-based vehicular networks, right? With our other
Yes,
side
yes, sir. Yes,
units,
sir.
right?
Yes, sir. Yes, sir. Because
No
for
more.
a conference,
Okay.
I can't include more results, so I will just present a
Okay.
part of the results, sir.
Yeah. Yeah. Good, ma'am. Good job, ma'am.
Yeah.
Thank you.
Yes, thank you, sir.
Thank you.
Thank you for your presentation, ma'am. I would like to call upon the next presenter, Shalini Puri, ma'am, to present a paper titled Semantic Similarity Model for Cross-Cultural Epic Narratives, the Mahabharata and the Iliad. Over to you, ma'am.
Yes, ma'am. Just a second. Is my screen visible?
Yes, yes.
Yes, it's visible.
Oh, okay, thank you. Just a second. Good morning, everyone. The topic of this paper is Semantic Similarity Model for Cross-Cultural Epic Narratives, the Mahabharata and the Iliad. We are the three authors, me, Pratiksha, and Anjali Dadij. This is my student's work, Pratiksha. She is actually on internship, so she was not able to give the presentation today. So I'm covering here the motivation, the problem statement, literature review, and then data set description, proposed methodology. Just a second. And then I'll discuss about the results, conclusions, and the future work. So motivation behind the work is that if we see that this is for the epics and we have considered Mahabharata and Iliad for the same, and if you see the literature work and in the existing works, there are many epics, but many researchers do not discuss about these epics and their large volume, because these are the large volumes of text, and the research works are not much about them. So we have taken considered the NLP and named entity recognition for the same. These are the research objectives for developing an NLP framework, evaluating them using summarization, semantic embeddings, and then analyzing the narrative elements. Coming to this literature review further, I just want to brief it out that we are proposing this study to investigate the overlap between two texts from Mahabharata and the Iliad and comparing the cultures based on the semantic similarities. We have applied NER, named entity recognition, abstract, and then abstractive summarization using Pegasus model, sentence level embeddings using the BG model, and the interactive co-occurrence visualizations. Further, we have evaluated the performance using ROJ 1, 2, and L metrics. And further, we have compared the results for both of these epics using cosine similarity, standard deviation, accuracy, precision, recall. This is a literature review, although we have considered some papers from, from 1983 and 1990 also. But this comparison, this table is from 2009 to 2024. And this is showing the epic text and from different references. You can see here the reference number 3 is for the contextual embedding. They have used BERT techniques, but they were not, considering the long narrative sequences. Further summarization tasks were considered in fourth, using denoising autoencoder. In fact, in all, I can say the literature review we conducted that they were not suitable for the long narrative sequences or long narrations. They were not taking the long such type of epics works. And for that, that's why we try to include the Mahabharata and Iliad. Further, we are actually planning to include something to make something for the Ramayana also in the future. And then we are trying that how we can find out the similarities between different type of epics. So we are trying to them consider them one by one. This is the data set description. Uh, the Mahabharata, you know that that was composed in the Sanskrit language, but we have taken its English version, and it is containing around 2 lakh Indian individual verses, while the Iliad is attributed to the poet Homer and containing around 15,000 lines. Both are the large volume of text, and they are taken from Indian and Greek cultures respectively. Iliad is comparatively shorter and more direct and focused narrative, whereas the Mahabharata is containing long contextual content, and so both are the main themes they are containing. That is, the themes are from the war, family, moral conflict, duty, etc. So we tried to find out the similarities between them. This is the proposed methodology we have considered for this, and we started with the text cleaning. As you know that first we acquired the data, and then we performed the text cleaning, tokenization. Then we performed NER, that is named entity recognition. Then we go ahead, we started doing summarization using Pegasus model. Then feature selection and similarity analysis. And lastly, we had the visualization using co-occurrence networks. So these, I should also tell you that just a second. We had the database including the chapter IDs, chapter text, named entities, summaries, and embeddings. So during pre-processing, the text was clean and just tokenized. As you, this is a basic process of each of the ML model. And then we started with the semantic chunking. Further, we recognized the named entities, and then we had extracted entities for duplicate and checking the duplicate entities, ordered them by the chapters, and then we applied character level entity sets for each chapter to create the character network visualization. Then we had a Pegasus model to generate the abstractive chapter summaries. Further, each chapter was limited to 1024 tokens because there were limitations. These are the huge text. So we had many limitations over there to consider this entire epic and to get the to get such semantic similarity network there. And further, the model selects the features using cosine similarities. The formula is also given in this PPT. So the cosine similarity metric was used to measure the thematic and semantic alignment between the chapters. Uh, it measures the thematic coherence of each chapter within the book for the BG model, which describe each chapter. And then chapters with similarity scores above, we actually took the 0.25 similarity score, because if we taking more or less, so it was not creating good results. So that's why chapters with similarity scores above 0.25 was indicating thematic overlap. So we took 0.25 to get semantic similarity, to distinguish all the meaningful themes and to just find out all the overlappings, etc. So further, these are the co-occurrence networks for the Mahabharata and Iliad epics. The character co-occurrence networks were generated using the library of graphs, and this illustrates how many of the most frequently referenced characters are represented by their node size and edge thickness. So this
Hello,
visualization was
ma'am.
generated. Yes, ma'am.
Just wanted to give you the 9 minutes marks. Speed up the presentation.
Okay, fine. So we have used these formulas, as you can see here, for the cosine similarity, and then mutual information, how to find out the similarities. Roche formula is also there. And these are the results we have found for Roj 1, 2, and L stand for long narratives. And then we found that the model was ineffective at reducing narrative details into a coherent summary, producing low F1 scores for 0.253 and 0.061 for Mahabharata. And the average cosine similarities was more than 0.58. That was indicating a high degree of internal semantic coherence for both epics. The accuracies they achieved that were 0.5, 0.813, recall of 0.5, 0.339. You can see here in this chart also. So these are the matrices. These are the comparative results for both of them. Further, this is the conclusion. You can see here the Mahabharat summaries and Iliad summaries as well, chapter wise. So this is a small work we have started for for Mahabharata and Iliad. We are trying to include more narratives, more different type of epics in the future, and we'll try to include something with the XCI also in the future, so that we can understand the content as well. We can interpret the content. So it's a very basic type of this is a model, and this is done by my UG student Pratiksha. So we started with that. Now later on we'll try to include some more things in that. So this is all about the work, and these are the references. We have taken around 24 references for the same, and accordingly we compared the work. So this is all about. Thank you, and if you have any queries, you can please ask.
Thank you, Dr. Shalini.
Yeah.
It's very interesting research that you are carrying out. Yeah, and I guess if I'm not wrong, I'm quite sure that very few researchers in India have taken similar kind of studies. Yeah.
Yeah, exactly. Actually, this was an innovative topic. So she is actually working with that. Now she is trying to make some good models for different Indian scripts and languages. So she is trying to include more, but this is a small work. We started with that. Now let's see.
Yeah, really appreciate, ma'am. And just I think some emphasis has to be given for this accuracy and F1 score, improving that.
Yeah, thank you.
Thank you, ma'am. Thank you, doctor.
Thank you, ma'am. Thank you, ma'am, for your presentation. I would like to call upon Mr. Avatapalli Krishna Likhit for his presentation of a multi-tool RAG framework for automated content summarization and interactive conversational AI. So, are you present?
Yes, ma'am. Is my voice audible?
Yes, it's audible.
Yes, ma'am. I will share my screen. Is my screen visible, ma'am?
Yeah, we can see the screen.
Yes, ma'am. I will go into. Yes. Thank you. Good morning to all. My name is Krishna Likith. So currently I am student in Amrita Vishwavidyapeetham from Bangalore campus. So my topic is on a multi-tool RAG framework for automated content summarization and interactive conversational AI. So myself, Avatapalli Krishna Likith, and my professors, Dr. Santan Lakshmi and Suja Palani under their guidance, I have done this project. So my paper ID is 766. And coming back to the introduction, what exactly the RAG? So the RAG is complete is nothing but the combines the retrieval and generation and context aware responses. Suppose if you have any documents, it able to retrieve the our necessary information, and it will able to generate the required information. This is what exactly the RAG. So coming to the chatbot, it enables the interactive question and answer session. Suppose we have any question and answers regarding to any particular topic, we able to clear the doubts with the chatbot. This is what exactly the chatbot. And summarization with the chatbot means how I implemented means with the user will read the summarization, and it will able to discuss if he has any doubts. He will interact with the chatbot and he will clear the doubts. And what exactly the LangChain means? The LangChain is a framework. It will interact with the LLMs and the tools and it will able to give us the information. For example, smart chartboard tools and agents. So these all are comes in the LangChain. We it is a bridge framework we can able to use, and we can build our applications. So coming to the objective, so there is a vast amount of video knowledge and website knowledge throughout the internet. So most of the tools will examine only the video part or a text part, and the student interaction also interaction has to be improved. And most and I think the YouTube is the best way, one of the best way to know more about our topics and all, because the YouTube is free of cost. And if we use the YouTube from if you get more information from the YouTube in the best way, then it will be very helpful for the students. So this motivates me to take up this project. And so by using the machine learning and deep learning concepts in the data science, I just able to started with this project, because the data science is rapidly growing field, and the jobs are also going to increase. The students, the upcoming students.
Sorry to interrupt, Mr. Likith.
Yes,
We
yes,
are
sir.
running short of time. Will you please go ahead to the problem statement?
Okay, okay. So problem statement is nothing but, so as I have already told, there is a rapid growth of the digital content in the YouTube videos and the websites. The more information is there, and the users to efficiently learn the complex topics like machine learning and deep learning. So most of the summarization topics will work on the YouTube or website. So my problem statement is work with the both URLs. And it what exactly it will do means, it will take the link, and it will able to summarize, and it will able to interact with the chatbot if as user has any doubts. And one more thing, I have integrated the tools and agents. So my idea is like, suppose if he wants to, he doesn't have he wants to know the outside information also with respect to the file. So tools and agents I have used Wikipedia and Arxiv tools. So using this, the user can able to interact with the outside tools also. So coming to the summarization thing, so initially we will start, and user will give the input URL and content type. It will decide YouTube or website, and it will able to extract the information. And it will able to
Are you
generate
changing
the.
the slides?
Yes, sir, yes, sir. I'm
We are
changing.
still seeing the first slide.
Okay. Now it's fine, sir, or
Yes,
it is
yes. Yeah.
so yes, the summarization will work for the start. The input URL you will give, and YouTube or website the transcript, it will able to extract the information from particular website and particular YouTube channel, and it will able to generate the summary. This summarization we have done using the OpenAI GPT 3.5, and then the summarization will store in the particular directory as an PDF. So then after performance evaluation, we have done using the bot. So coming to the chatbot interaction, once the summarization is generated, the user will read the content inside the summarization, and he wants to clear the answers with the chatbot. And so here the rack setup is comes into the picture. The vector store, we have used the FIAS, Facebook AI similarity search, and three types of agent tools we have done. First one is summary search. If the content is from the summary, means it will able to extract from the summary, and it will interact with the LLM, and it will able to generate the answers. And second one is Wikipedia. If the content is not in the summary sheet, and it will able to take the agents, it will able to call the tools, and it will take the Wikipedia information, and it will give the information. And coming to the Arxiv tools, coming to the, if the user wants to know about the more research papers about the particular topic, the Arxiv tools used. For example, if he wants to user wants to know about RNN, the recent research papers, means we able to retrieve the information from the recent research papers, and it will provide the information. So like this, the user will give the query, and the agent and tool section, it will come and execute the tool, generate the response, and performance evaluation done. After performance evaluation, again it will point to the user query, and like this we able to interact with the chatbot. So as I have already told, Arxi, Wikipedia, and some research I have used. The Facebook vector similarity, FIAS we have used. So the performance evaluation, context recall, relevancy, faithfulness, semantic similarity, we have used. And so coming to the how we have implemented means chatbot performance using YouTube, chatbot performance YouTube machine learning, YouTube deep learning, website machine learning, website deep learning. Total 15 YouTube videos for machine learning and 15 YouTube videos for deep learning, same as 10 website information, 10 website for the both machine learning and deep learning. We have calculated the performance evaluation using these four, using the Gamma, Llama, and Mixtral for all the things. We have got accuracy, very good accuracy, but relevancy scores are very low, and I have investigated why the relevancy scores are very low. And what I have understand means like what it able to extract the information exactly that is matched with the LLM generation answer, then only the relevancy score is high. Even we have the same final answer summary, if the exact information same only means, then able to the high accuracy it is getting. So we have investigated this one, and this one YouTube deep learning concept, we have generated the performance evaluations. So for this we got the Gamma 2999B. We got the context recall 0.93 and the average score is 0.625. And then after this comes to the website machine learning and website deep learning performance. We have investigated for all the three models, but here we have kept in the Llama for good visual thing and all. Here also the context recall got very good for the website machine learning and the deep learning thing
Hello.
and all. Yes, ma'am.
Hello, sir.
Yes, ma'am.
So we have reached the 9-minute mark. Can you
Yes, ma'am.
please speed up your
Yes,
presentation?
ma'am. Yes, ma'am. I will complete, ma'am. So these are the sample questions I have used for the YouTube machine learning, deep learning website and deep learning. We gone through the different concepts and we have asked the chatbot and we calculated the performance evaluation. So these are the sample question and this is the conclusion. So as we have already told, this will be very useful for the students. So for the in the future work, if we bring this to the low resource languages like Telugu, Tamil, Malayalam, and Kannada, this will be very useful. And if you generate the chatbot with the visual side also, it will be more helpful for the students. So these are the some sample references. Thank you.
Sir, do you have any questions?
No, ma'am. That's all.
Okay. Thank you, Likit sir, for your presentation. You can now
Thank you.
stop sharing the screen.
Thank you, ma'am.
Now, I would like to conclude our session. I would like to sincerely thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for all of us. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. And we'll be surely happy to have you in the 11th version in 2027 as well. All the presenters would be getting their certificates through email within 2 working days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of SmartCom 2026. I would like to thank our session chair, Dr. Prasanna Jaichan Shetty, for chairing the session. And here is a token of appreciation to the chair on behalf of Team SmartCom 2026 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, sir.
Thank you so much. Thank you, Ms. Gayatri, and all the organizations of GR
Yeah.
Foundation. Thank you so much.
Yeah, thank you, sir. Thank you for your presence.
It was my pleasure to attend this session, and just in two lines, I would appreciate the efforts of the researchers. There were around 10 papers from different domains, not only from healthcare, climate, maybe communications, security, but also the papers highlighted the social and cultural aspects as well. And that is where the diverse platform, the diversity provided in the research on the platform of SmartCom. And it gives a good sign for this particular conference. We have received the papers right from different parts of India, abroad, as well as on the different domains of technology. Yeah. Yeah.
Yeah.
Now with
Thank you
that,
so
I
much, sir.
congratulate the organizing team as well as all the researchers. Yeah. Thanks. Thank you so
Yeah,
much.
thank you so much, sir, for your kind words. Before finally ending the session, I would like to request everyone to switch on your cameras for a quick snapshot of the virtual conference. Can you all switch on your cameras?
Ma'am, put the flyer of the conference.
Yeah, just a second. Just a second. Okay, thank you everyone for your presence. You can now leave the meeting. Stay safe. Take care, everyone. Thank you.
Thank you, ma'am.
Thank you
Thank you,
so
ma'am.
much.
Thank you, sir.